following is a test of the fuel cell. We need to fill the hydrogen tank with hydrogen and then adjust it to the appropriate pressure. The pressure should be less than or equal to 0.5 bar. Fill the water tank with water. Adjust the electronic load clockwise to the maximum, which is 12 ohms. Next, power on. Here, I also pair this software. All are OK. The software uses a network cable to connect the communication port on the right side of the device to the communication part of this computer. This is a software CD. It also comes with a USB network card, which can be used if the computer does not have a network port. Next we start from the touchscreen. Now we can see the current power generation voltage is 14.3 volts and the current is about 1.2. It should be noted that this is the number 8 solenoid valve, which is the solenoid valve for hydrogen output. It controls the time of its reverse and stop. Now it is on for 1 second, then closed for 15 seconds, then turn on 1 second, and then closed for 15 seconds. It must ensure that after the hydrogen and oxygen react inside, when the concentration becomes lighter, it will be discharged again. The initial while is 1 second and 15 seconds. We can adjust it through the panel, and it can be also adjusted to 10 seconds. It can also be adjusted to 2 seconds here. Some current electrical parameters such as voltage and current will be displayed here. We can take a look at the current, voltage, and other parameters. Now let's take a look at hydrogen. After the hydrogen comes out, this is the solenoid valve. The current pressure inside, as the closing time is long, its pressure value rises quickly, and now it is 0.05 ampere. When the solenoid valve is open, the flow can enter, so the flow will flow out. After the hydrogen comes up, it is now on 2 seconds, then closed for 10 seconds, a circle state. You can see that the straight light will display the current state of the solenoid valve. We can see that the current air is 5 liters per minute, and the temperature, after it comes out, the temperature rises because it reacts inside. We can also see the water cycle. The current temperature entering is about 14 degrees, and when it comes out, it becomes 15 degrees because it takes away the heat inside the fuel cell. And then you can also see its current flow rate of 0.349 liters per minute. We can also see here that humidity in the current room is 78%, and the current indoor temperature can be seen here. Current electronic loads, current, voltage, power, and other electronic parameters will also be displayed here. Because the maximum resistance is 12 ohms, we can rotate counterclockwise to reduce the resistance value, and the corresponding current will increase. As we reduce the resistance value, the resistance will reach about 5 amps, and the current of about 5 amps will reach about 60 watts. But it will have this instantaneous voltage reduction because we are now connected to the hydrogen tank now. We are using hydrogen fuel hydrogen generator, and its hydrogen supply is limited, so when there is a large load, it will disconnect. We adjust the resistance to the maximum, and after adjusting to the maximum, the load will be smaller and the current will be smaller. You can see that it becomes a few tenths of an amp. Next, let's take a look at the software side. we can also change it here. After we adjust it to 1, the touch screen also becomes 1, and then we change this 10 seconds to 15 seconds. This will also become 15 seconds, which has no effect on each other. And it can also display some status indicators displayed on the current touch screen, such as voltage, current flow, and other electrical parameters. We set it to 2 seconds, which means it will be on for 2 seconds. Some current electrical parameters such as voltage, current, power, etc. will also be displayed here. Let's look at this side again. This is a curve of 5 temperatures on this device. Then here's a curve of the voltage, current, power on both sides of the resistor. This is the pressure sensor, which is the change of pressure sensor in the hydrogen circuit, the change of pressure value. This is the change of the 3 flow sensors. F1 is for air, F2 is for hydrogen, and F3 is for water circulation. The following is a curve of hydrogen. You can also export this data table. This is the data table just exported. Let's take a look. The first line is the serial number, the second line is the time, and all the data after that are all the data in the experiment process, which can be displayed here. Then the experiment is completed, so the whole function can be displayed, and then we can also turn off the device through the software. Click off with the mouse. It is the same as this touch screen. After the experiment is completed, we can turn off the software. In the upper right corner, turn off the main power. All the corresponding hydrogen hand valves are closed.